Hey everyone, Dr. Mikola Rashik of Merigenomics here. I have a fascinating video today for you that talks about the value of sunlight, and it's one of those episodes that might help you understand as to why I invest so much time in spending in nature. If you've been following my channel for a while, you probably clued in by now that I almost never record anything indoors, and I spend as much time outdoors as possible. And there's numerous scientific theories about it as to why nature can be of benefit to you. Today's episode can help you understand one of these concepts, and it has to do with sunlight. And this is the topic I wanted to tell you about for a while. And it's an article that I think one of the Patreon members sent forward to me. Really cool story and full of surprises. And let's break it down as to why it's so important to spend time in natural light, and why at the moment we are doing ourselves disservice by creating an environment where we are spending less and less time in such conditions. All right, so in order to explain all of this to you, first let's talk about light. So sun emits light, obviously, but it emits a variety of different kinds of light. We break it down based on wavelengths. So there's a variety of different wavelengths of light. These lights are sent to us as I'm gonna call it pockets of energy called photons, and they'll have different properties. So some are very tight wavelength, and some wavelengths are very spread out, and it's a whole spectrum. And the whole range is roughly somewhere from 250 nanometers. The numbers doesn't have to be exact, all the way to several thousand nanometers. And it starts with the UV light. That's the one we all know is harmful. That would be somewhere around the 250 nanometer spectrum. Then after that we have visible light. That's the one that obviously is most familiar to us. This is the one that allows us to see all the colors. And that range is somewhere from, say, 380 nanometers to 750. And that has a spectrum of colors. So it starts with like violets and blues and greens, goes to oranges and ends in reds. And that's the visible light again. Then we go into near infrared, and the near infrared is somewhere between 750 to maybe, give or take, 1200, maybe a little bit more, nanometer wavelength. And beyond that is infrared. And we don't see really in UV, or we don't see in infrared, we only see the visible component. So that's basically the breakdown of light. And now, light is not benign. We all think of light obviously as UV is dangerous, and it's true, it is, but all form of light, in theory, you could argue, could be dangerous, because all forms of light will produce what is referred to as free radicals in your body, in your tissues. So all forms of light can cause development of these reactive species inside your body. And this is really important, and that includes visible light, that includes near infrared, and UV. We're all familiar with UV, obviously. That's damaging. And our biology has built different mechanisms to deal with all of this. So keep that in mind. All form of light can lead to the development of these damaging species. And I apologize for huffing and puffing. Rapid elevation gain. And so keep that in mind. And the authors posit that, The visible light can also be dangerous, especially on the blue spectrum, because it's not just how much each pocket of light creates reactive oxygen species or lipid, chemically altered lipids, which are fats, which are all chemically reactive. It's also with the dosage. So the blue visible light, because of how much of it we can be exposed, can also lead to quite a lot of such damaging species. So keep that in mind. Now, when it comes to UV, because this is what we're all familiar with, think of it this way. Skin is what protects us from UV. UV only goes through your skin, maybe up to a few millimeters most, and your skin takes all the brunt, all that damage. Oh, let me show you what's now up ahead of me. So maybe I should have waited for the valley to film. We're going straight up there. Look at these views. So skin will take all of that brunt, and this is why we develop skin to shed, and we shed it rapidly. Within approximately 3 weeks, you will literally change your skin, give or take. And this is why we shed skin all the time. This is partially why we leave genetic trail behind us all the time wherever we go, because we have skin, we shed skin all the time. And it's because it protects us all the time from damage. So visible light also doesn't penetrate very far into the body. And and similar idea, your skin will protect you a lot from these damaging agents of light. But now we get to near infrared, and most of sunlight is composed of near infrared. The bulk of light that we get exposed to is near infrared, and your body is made to absorb that light, and it can penetrate deep into your tissue. So, as a matter of fact, according to these authors, they claim that our biology, our body is designed on purpose to really absorb lots of infrared and allow it to go deep and spread all over our tissue. And I'm gonna tell you right away in a moment as to why. Let me show you. Look at these cool little pillars behind. So why infrared? Remember, I said all light can cause creation of, say, these damaging agents. So then what's so special about infrared? Okay, so that's the breakdown of light. And as a consequence, the most light that we absorb is also infrared. And our body is designed to do it, so much so that of the anywhere between 20 to, they say, 37 trillion cells that make up our body, bulk of your cells in your body will be exposed to infrared. And when you're a child, because of the depth of penetration of infrared through your body, because it can go quite deep, as a child, all of the child's body can be exposed to infrared radiation from the sun. So the author or authors, I don't remember if it was multiple authors or not of this article, they might be having just one. They did like a rough calculation showing how much infrared are we absorbing throughout life. And a child, for the first part of life, absorbs almost entire body, or all of the body will be absorbing infrared. Same with pregnancy and fetus. Pregnancy is designed in such way, including the amniotic fluid, to help direct and channel infrared light so that the fetus can be doused in it as well. Because when we get the infrared from the sun, it's not that just from the sun, it will bouncing off of things, and we also get it that way as well. So, and our biology, according to these authors, is made in such way so that this infrared can be channeled through our biology throughout the body. So that's about infrared now. And I'll show you an excellent example of what they mean, how biology can channel literally direct infrared to different areas. And I'll show you a picture of a brain as well, how that does. But why infrared? And now we're going to introduce another molecule, and that's melatonin. Now we all know melatonin very well. Most of us, there's two types of melatonin though. There's one that reacts to dark and one that reacts to light, right? So it's like Mr. Jekyll and Dr. Hyde type of thing. Or was it the other way around? Either way, there's two versions. We all know the one that reacts to darkness, the ones that puts us to sleep. So that's the one that when there is lack of blue light being recognized by our receptors, our pineal gland inside our brain then triggers release of melatonin into circulation. We all know about this. We pop melatonin pills to go to sleep because that works with our circadian rhythm, puts us to sleep. But it's not just to put us to sleep. That circulatory melatonin is there to help protect you from all those damaging chemicals I was telling you about, those reactive oxygen species, reactive nitrogen species, reactive lipid species, which are fat molecules, which are constantly produced in our body through either light exposure or through your simple metabolic processes, such as breathing, and like I'm doing right now. And that needs to be somehow quenched. And melatonin is your super molecule that does that. I did a couple of videos dedicated to just melatonin and how valuable it is, how important it is to help to protecting your mitochondria. So check that out. And the take-home message always lately in my videos is, how do we protect our mitochondria? Because mitochondria dysfunction is what starts to emerge as issues that lead to a lot of our chronic issues, including spike protein injury and cancers. So I did a series of videos dedicated to these topics, so check those out as well. So that's the melatonin that's in your circulation. But there's another entire group of melatonin. There's emerging science coming out on that, and that's subcellular melatonin. That's a melatonin that's produced inside your cells. Mitochondria is involved in that. It protects your mitochondria. It protects your cells from all that damage. That melatonin stays in its local environment, and it's the infrared, the bathtub of infrared that you go into, that is the element that helps to stimulate its production. And this is where that infrared exposure comes in so handy and so important. And studies show that if you get lots of exposure during the day, you accumulate this infrared melatonin because of infrared exposure, so much so that you might then require less amount of circulatory melatonin at the end of the night to help you deal with all that damage, because you protected yourself through melatonin that was stimulated to be produced because you were exposed to the infrared from the sun. Okay, this is amazing. All right, so that's your two versions of melatonin. All right, so then how and why is this an issue? And the issue is that, let's talk about the good things and the bad things on all of this. And the issue is that we are generating a society that, as a consequence, we have less and less exposure to infrared, to sunlight. And as a consequence, we have less and less exposure to infrared and less production of melatonin. And you have fewer and fewer of this protective mechanism, versus we have evolved to work with sunlight and I'll show you this picture. So trigger warning, this is a picture of a brain, but it's not very visible in terms of brain. It's a slice of brain. I don't even know which species. Maybe it's a good thing. I don't remember off the top of my head. In a petri dish, and it's backlit by infrared, and it shows you how the brain is designed to scatter the light so that brain can really absorb as much infrared to have this protective effect of melatonin as much as possible. And the authors claim this is done on purpose throughout entire biology, and we are yet to discover the amazing ways that our biology is made in order to make sure that light is channeled throughout our body to reach different nooks and crevices. So there's the image of the brain, and you can see how the light goes in, scatters, and goes in, even penetrates the deep crevices of the brain. Remember, the surface of the brain is gray matter, and the gray matter, as a consequence, gets most of that infrared. And this is one of the ways is to basically help to protect the brain from all the damage associated with those free radical chemicals that we have no choice but to produce naturally. Okay, so that's the image. Now, what are the issues? The issues that we are facing as a consequence, there's multiple, because we are turning into society bigger and bigger steps where we are now exposing ourselves to visible only light. So our light bulbs no longer produce infrared, those incandescent old school light bulbs that we all grew up with. They're wires that heat up and they emit light from wire being heated up, and that produces infrared. And we have less and less of exposure. And in the meantime, we have more and more exposure to that blue light of the visible spectrum. And there's one take-home message that I would want you to take. The least thing we can do is, besides obviously getting outdoors, spending as much time in the sun as possible, well, with limit, and I'll mention that in a second too, then is switch your computers so that they do not emit blue light anymore, because the author showed that from the visible light, blue light will be producing some of the largest quantity of those free radicals from the visible light spectrum. And they mentioned, you think it might be all benign, but they mentioned 8 hours in the office exposed to nothing but visible only light with no infrared is the same as if you spend half an hour on a beach in the sunlight. So take a pick, 30 minutes on a beach or 8 hours in a printer room. So your choice. I would take the beach, obviously. And here's one of the issues. They mention that, look, there is well-documented concept that in last few decades, cancer rates amongst Caucasians, basically white people, skin cancer rates are increasing. And which is paradoxical, because so is the use of sunscreens, sun blockers. And of course, causation is not correlation is not causation. And just because you see an increase in sunscreen use, an increase in skin cancers, doesn't mean that sunscreen causes skin cancers. And I still wouldn't think that's the case either. However, this is what the authors mention. There's something that we might be missing. Let's see if we can see the peak where the end goal is. We're trying to get to the top of the mountain. That's probably the peak right over my head. So, and what they're saying is that it's not that the skin cancer sunscreen causes skin cancer. What happens is sunscreen gives a incorrect illusion for people that they're protected from the sun, and as a consequence they spend too much time in the sun, and as a consequence they get that infrared, right, but they you can max that out, and beyond that, you will still be producing those free radical species that will be damaging to you. So it leads to people being unnaturally exposed to too long of a time to the sun versus what would have happened otherwise. People would have feel the effect of the sun naturally and get out of the sun. So you would, excuse me, don't mind the snot, and you missing that concept of natural protection. So we are now spending more light in unnatural light that can still cause effect of that wavelength. We are potentially spending too much sun when we're using sunscreen without realizing that the reaction of the skin, natural reaction of the skin to the sun would have been protecting you. So that's another issue. And a third one they also mentioned is that cancers. It's very deeply understudied as to effect of light on cancers, but it seems that the more blue light you expose breast cancer cells, the faster cancer cells can grow. Now, these cancer cells, the cancer cells typically have more water in them. Water, apparently, and I hope I'm getting this right, can help absorb more of that blue light spectrum than not. And that might help be the reason why cancer cells seem to be more reactive and help the blue light components of visible light might help cancer cells, versus it's also known that cancer cells can also easily absorb infrared, and we need to study this more. So there's multiple negative effects. On top of that, I mentioned those blue light, I should mention, when you get hit by UV, those free radical species, they're very short-lived, but when you get hit by the visible light and the blue spectrum, that targets more of those fat tissues, fat molecules, and when you make them reactive, they last a little bit longer. Well, it's a tough step here. So that's another potential issue. All right, so that's the bad stuff. And the authors showed this very cool image where they estimated how much infrared is disappearing in our lives because literally governments are enacting policies that are purposely shielding us from infrared light more and more and more. The exact opposite of what we possibly should be potentially be doing according to these authors. And they showed this very cool graph where they estimated the effect of how the infrared light is disappearing. All right, so then what is the good thing? Let's wrap it up on a good note. Well, you can easily get lots of infrared by getting outdoors and spending time in the sun. Now, sun, obviously, as I mentioned, there is a limit, so you shouldn't burn yourself, but eventually melanin as well, the pigment in your skin, can help you protect you from some of that. And the authors even mentioned, you know how we have different ethnicities with different amounts of melanin in skin too, and depends on where you live on a planet, where you evolved as humans on the planet. And for example, Caucasians are white because they want to absorb more light because they have less exposure to it, right? And then we have people who are more dark skinned, they have more sun exposure, more protection in relation to that infrared. But they're saying the babies or even fetuses, I should say, of darker skinned people, their melanin doesn't show up to the same extent as what can be later on seen in an adult version. And that is also a naturally evolved method of making sure that the fetus absorb in a mother's womb gets to absorb as much infrared for protective purposes as possible. And even a pregnancy, the way it's designed is for the fetus to be exposed, the skin stretches so that there is a very thin layer and the fetus with the amniotic fluid that channels the infrared. It just all helps to make sure that the fetus can be doused with infrared in order to protect the fetus from mutations and so on. So sun exposure, but sunlight is not all equal, and different times of day will give you different amounts of infrared. So sunrise and sunsets are the best because the infrared amount doesn't change. You still have the same amount, but the amount of UV is different. So sunsets and sunrise gives you best ratio of infrared to UV. So it's the healthiest component. The author gave estimate of about 3-to-1 ratio of infrared to UV versus, let's say, in the middle of the day when sun is at its zenith, then that ratio is more like 1-to-1. Look how cute that is, right? So that's the advantage. I sometimes set my alarm now these days just so I can wake up early enough to see the sunrise. Not just to get the infrared, but because where I live in Alberta, prairies, sunset and sunrises are incredibly beautiful. It's so stunning. So think of it that way. Of course, you can try to use more romantic candles that will give you lots of infrared. Go back to incandescent light bulbs as opposed to LED. And my understanding, some LED will be visible only light. Some of them might have infrared. But your goal is to get light bulbs that have infrared. But the best of the best source of infrared for you in terms of ratio or in terms of amounts, this was a surprise, but it makes sense, is fire. And the reason why is because you can think of fire as condensed sunlight. Obviously, wood, to grow wood, you need sun exposure, and think of it almost like it's a sunlight that is trapped. And when, say, sunrise or sunset gives you 3-to-1 ratio of infrared to UV, fire exposure to like a campfire is 10-to-1. And this is why you feel so good at the end of the night when you gather around campfire and so on, why you sleep so well, because you got a super healthy dose of infrared that gave you lots of melatonin production. You can produce ATP and your body is protected. And the last figure I'll show you from the paper is how it works biologically. So it shows you skin, you see these circles, think of like each circle is representing a cell. Big steps, I'm scrambling as I'm talking. And if you have lots of infrared exposure, then you can see just top layer, the skin's top layer, stops the UV, takes the damage. It will all be regenerated, so that's okay. It's made for that purpose, right? No problem. But the infrared penetrates and it gives all your cells a huge dose of infrared. They're well protected. Infrared on top of that, it can dilate your blood vessels. This could be via stimulating nitric oxide production, which then brings the blood flow, and that blood flow in turn can collect all of the waste. Your tissues are well cleaned, you're well protected. Now, when you don't have infrared, which is now what we're doing in our society more and more and more, and because fewer and fewer people go outdoors and film their YouTube videos outdoors instead of, they mostly do it indoors, then what happens is you're losing that deeper protection via melatonin from all these reactive chemicals that are naturally produced all the time in our body via breathing, via metabolism, via exposure to oxygen and so on. And you accumulate that and you start having issues and damage accumulating deeper inside your body. So this is my summary for you as to why you should get out into outdoors as much, why it's so important for kids to play outside as much as possible. It's so protective for them. And why, if you want to learn more about this content, why nature is so healthy and so good for you, please hit that subscribe button now so I can deliver that for you in the future when that time comes. I never know when that will be. And also, on top of that, please give me a like, please leave a comment, Let me know if you would now consider it infrared bath or not, or whether this inspired you to get outdoors or not, or if you think this is quackery or not, which is totally fine. Like, this is all speculative. This is very new information that is being just published in recent years. So, as all of my videos, a lot of it is on the fringes of science. And then, of course, the last thing I'll mention before I say goodbye, one more view, is that please check out my Patreon account, where I post additional content that does not make it to YouTube. Some of it is free, some of it is behind paywall. Lots of free content though, so please still check that out and sign up. You don't need to be paying, supporting Patreon, but if you are, then you see all of the content, including the videos that do not make it to YouTube, and you get to pick as to what we should post together on YouTube or not. Adios, everyone, and I will see you when another dose of sun is necessary. Bye, everyone.